Hey physics students, yesterday I posted all the materials for Unit 1, and we're going to start this unit by describing how things move, also known as kinematics. Later in the unit we'll talk about why things move and the forces and the energy that causes motion, but for now we're just using models to describe it. One of the models for describing motion is motion maps. We shared a motion maps reading that you can see on the left, and also the quiz on the right. We'll do the corrections for that right now. So here are the steps that you're supposed to follow to draw a proper motion map. But let's look at this concrete example. Here's the scenario. A skater on the Harbor School basketball court is moving 2 meters per second. She starts at the baseline, rolls for 3 seconds, stops at mid-court for 5 seconds, and returns to the baseline going 1 meter per second. Make a motion map that represents this scenario. So as with most problems, I would read this a couple of times so you start creating a picture in your mind of what this situation is. You can also draw a picture, or since I made these graphics, I'm going to do a little bit of animation, live animation. She starts at 0 meters along the baseline, and she goes about 2 meters per second. So I'm going to try to do that. 1, 2, 3. Stays there for 5 seconds. 1, 2, 3, 4, 5. Then goes in the opposite direction, 1 meter per second. All right, so how do we represent that with a motion map? Well, let's follow the steps. Step 1 is draw the dots indicating the position of the object at equal time intervals. So each dot represents a time interval, and it also is located at the position where the object is. So let me just move this over. If she's moving 2 meters per second for 3 seconds, that means she goes a total of like 6 meters. So I'm going to write each one of these is 1 meter. 4, 5, 6, 7 meters. Okay. Make sure you use a different color when you annotate these PDFs because we want to be able to distinguish your work from the worksheet. So now I'm going to write these dots in red. So it says that the skater starts off at the baseline, so it's 0. And then she's moving 2 meters per second. So each dot is a second and 2 meters away from the starting point position. So there. That's 1, 2, and 3 seconds. Then it says that she stops at mid-court for 5 seconds. So when an object is stopped for several time intervals, you draw multiple dots at the same position. So I'm going to draw 1 here, 2, 3, 4, and 5 seconds. Then she returns back to the baseline going 1 meter per second. So 1, 2, 3, 4, 5, 6. Now we're done with the dots. Now we have to attach the arrows. And you want to make the arrow about half the length of the space between the dots. So like that, like that, like that. So it shows the direction of motion. And then when she's going back, the arrows are going to be shorter because her velocity is less. She's not going as fast. So from this simple diagram, you can tell how far she's traveled, her change in position. You can also tell how long she was skating for, right? If you count the dots, you have, start here, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 seconds. And you can also infer how fast she was going, or her velocity over those different periods. Now let's move on to the quiz. Draw a quantitative motion map for the following description. A bicyclist speeds along a road at 10 meters per second for 6 seconds. Then she stops for 3 seconds to make a 180-degree turn, and then travels at 5 meters per second for 3 seconds. Let's first figure out what we want our intervals to be. So if she's going 10 meters per second for 6 seconds, we can assume that she's going to travel about 60 meters, right? So the intervals should be 10. Hey, there's a skater. You can't see it, but I can hear it. All right, 0, 10, 20, 30, 40, 50, 60, 70. Let's just assume that she starts at a starting position 0. And it says 10 meters per second for 6 seconds. So that's 1, 2, 3, 4, 5, 6. Then she stops for 3 seconds. 1, 2, 3. And travels at 5 meters per second for 3 seconds. So half the velocity. 1, 2, 3. Once we're finished with our dots, we can draw our arrows. 1, 2, 3, 4, 5, 6. 1, 2, 3. And you're done. And here's the last question. Draw and label a quantitative position time graph for the motion map below. Now, we're going to be looking at position time graphs a lot. Here's the thing about position time graphs. First of all, time is always going to be on the x-axis. Okay? Time. Position is on the y-axis. And we usually label position as x. So that's a little confusing because time is always on the x-axis, but the position x is always going to be on the y-axis. So you just kind of have to get used to that. It's not because it's the x-axis, it's just because we usually label position x. So in this motion map, you can see that the first dot is at 1 meters, which means that at time 0, right? At time 0 seconds, the object is starting at 1 meter. Let me just insert the units here. And on the x-axis, that's in seconds. On the y-axis, it's in meters. 1 second later, it's at 2 meters. 2 seconds later, 3 meters. 3 seconds later, 4 meters. 4 seconds later, 5 meters. And then you have these 3 seconds here where the position doesn't change. So what that means is that you have the object staying at 5 meters for 3 seconds. Let me get my nifty ruler here. Oh, a little too far. Wait from there. Get my little eraser. And there you go. There's your position time graph. All right, I hope you liked this video. We're going to do a lot more of these. We're going to do multiple representations of motion using graphs, using position time graphs, velocity time graphs, and then further down the road, acceleration time graphs.